Hi everyone, in this video we're going to look at rational exponents. So let's say I had x equals 5 to the 1/3 power. So I have a fraction that is an exponent, which is just known as a rational exponent. I want to know what is x to the third. So all I'm going to do is I'm going to take each side and raise it to the third power. So that would tell me that x to the third equals what? So I have a power raised to another power, and the power to power rule with exponents tells me just to multiply them. If I do 1/3 times 3, I get 1. So really, x to the third equals 5. So that means, therefore, x would equal what? So if I want to solve for x, if I had this equation here, I would need to take the cubed root of both sides to undo a cube. And when I do that, I get x equals the cubed root of 5. So as you can see, since x was equal to 5 to the 1/3, x also equals the cubed root of 5. And these two expressions mean the same thing. So when I'm looking at rational exponents, which are just exponents that are fractions, I'm looking at a base to a power that's a fraction, 1 over n. So a is your radicand, that's the expression under the radical, and n is your index of your radical. So as you can see here, the n is the index and your a is your radicand. So all these are just rewrites. For example, in these first four problems, we have to use radical notation to write those expressions and then simplify if possible. So another way of saying 4 to the 1/2 is to take the 4 and make it your radicand, and then the 2 is your root index. Now, normally for square roots, we don't write the 2, but it's understood that it's there. So I am going to get rid of it because it's not normally there. Anything to the 1/2 power is just a square root, and we know the square root of 4 is 2. As we learned up above, anything to the 1/3 power, if I was to rewrite it, is just a cubed root. So the 64 is your base, and then your root index is your 3. And we know that the cubed root of 64, or what number to the third power equals 64, would be 4. For letter C, I have a power to a power, so I could multiply the two powers together. 8 times 1/4 gives me 2, so that would be 81 squared. But I'm going to rewrite it, and this would be the 4th root of 81 to the 8th. And we learned in one of the other sections that really you just divide the index into the power, and 4 goes into 8 2 times. So we get 81 squared. And 81 squared comes out to be 6561. For letter D, I have 5 times 1 y to the 1/3. So I've got 5, and then I have the y is your radicand, and it's to the 1/3 power, so that would be the cubed root of y. Okay, let's practice some more. So now what happens when the numerator is not 1? Okay, if you have m over n. As you saw up above, where this was a 1, that really is just your power. So as you can see here, a to the m over n is just the nth root, so the n is your index, and then the m is your power. You can rewrite it like this, or you can place the power on the outside of parentheses. So if I was to take letter A and use radical notation to write that, the 4 would be your radicand, The 2, again, is your index, but, we don't really have a 2 in there. So again, I am going to remove that. And then the 3 is your power outside. You can also write that like this. Both of those expressions mean the same thing. So the square root of 4 we know is 2. And then all I'm going to do is 2 to the third, which equals 8. So my final answer there is 8. For letter B, I have this negative here, and then I'm going to rewrite the 16 to the 3/4 as 16 for my radicand, the 4 is your index, and then we're cubing it. So I know that the 4th root of 16 is 2, because 2 to the 4th is 16. So basically I have this. And remember, order of operations tells me I have to take care of powers first before multiplying by anything. 2 to the third is 8, so we get -8 for our answer. In letter C, if I was to rewrite, I have the square root of 1/9 to the third power. And we know the square root of 1/9 can just be split into the square root of 1 over the square root of 9. And the square root of 1 is 1, and the square root of 9 is 3. So what you have there is 1/3 to the third. And when I have a quotient to a power, quotient just means divide, you're basically going to raise the numerator and the denominator to that power. So this is really 1 to the third, which is 1, and 3 to the third, which is 27. In letter D, again, I have a radical, and my radicand is going to be 4x minus 1. This is the 5th root, and I'm raising it to the third power, which you can also express like this, except I would put the 4x minus 1 in parentheses to the third. And there is nothing you can do because you're looking for a 5th root, but you only have 3 of these, so you can't get a group of 5. So you would just leave your answer like that. So again, rational exponents really are just rewrites. They're radicals in disguise, and then all you're doing is simplifying. If you'll remember, when we have negative exponents, we use the same rule. We don't like to keep negative exponents. So we take whatever the base is being raised to the negative exponent, and it moves. So it would go, in this case, to the bottom. If it's in the bottom already, and if it's negative, it goes to the top. So here, if we need to rewrite this expression with the positive exponent, we can't leave 16 to the -3/4, so we would rewrite that as 1 over 16 to the 3/4, which I know is really 1 over the 4th root of 16 cubed. And the 4th root of 16 is 2, because 2 to the 4th is 16. So I have 1 over 2 to the third, which gives me 1/8. For letter B, you have 1 over -27 to the positive 2/3. Notice that I didn't change the sign of the 27, so when you move the term, it doesn't change the sign of the base, just the sign of the exponent turns positive. And then again, we're going to rewrite this, so it would be 1 over the -27 goes inside, the 3 would go here, and then the 2 goes outside. So if I work inner to outer, the cubed root of -27 is -3, because -3 to the third is -27. And then don't forget you're squaring that, so you would get 1/9. It's important to remember all of the exponent rules that you've seen before in Algebra 1 and Algebra 2, and that we've discussed and come across in this class as well. So we're going to use those properties to simplify the following expressions. Okay, so when I multiply and I have like bases, so the y's are called the bases, and then 1/3 and 5/3 are your exponents. When you multiply like bases, we add exponents. So this is really just y to the 1/3 plus 5/3. And 1/3 plus 5/3 have the same denominator, so I'm just going to add the numerators. 1 plus 5 is 6, and 6/3 is 2. So that would just simplify to y squared. And again, you have these different rules to review, and the one that I just used was the product rule for exponents, where the bases are the same and I add the exponents. If you take a look at letter B, I am dividing now 7 to the 1/3 divided by 7 to the 4/3. So which rule would I be looking at? Okay, and that would be the quotient rule for exponents. When you divide like bases, you subtract the exponents. So here, this really simplifies to 7 to the 1/3 minus 4/3. And again, you have the same denominators, so we could just subtract the numerators. 1 minus 4 is -3. So really you have 7 to the -3/3, which reduces to 7 to the -1st, and we can't have negative exponents. So to fix that, I would just put the 7 to the 1st on the bottom. So my answer is 1/7. Letter C utilizes the same rule we used for A, which is when you multiply like bases, you add the exponents. So here this would just be m to the -4/7 plus 6/7. And if I add -4 plus 6, I get -2. I'm sorry, +2. So this would be m to the 2/7. For letter D, here I have a division, so a quotient, but in the numerator I have parentheses and then a power. So I'm going to take my product to a power rule, which says you're just going to distribute the power to each of those bases. So in this case, I would take the 5 and distribute it to the 2, so it would be 2 to the 5th. And then I'm going to multiply 5 times 2/5, which gives me 10/5, and 10/5 reduces to 2. And then I would have y to the -5/3. And then in the denominator, I have x squared y. So to simplify, 2 to the 5th gives me 32. We have an x squared divided by an x squared, which just cancels out. And again, you're dividing. So we would subtract the exponents. 2 minus 2 is 0. And anything to the 0 power, as you can see in this rule, is just 1. Okay, so that's why they cancel. And then I have y to the -5/3 divided by y. So here what you're doing is -5/3 minus 1, right? Because we have a 1 here. In order to subtract them, I need to have the same denominator. Or I can just convert 1 to 3/3, which is really all 1 is. So if I want to do -5/3 minus 3/3, I would get -8/3. And we can't have negative exponents, so to fix that, I'm just going to take the y to the -8/3 and place it in the denominator to make it positive. And one last thing we're going to look at here is using rational exponents to simplify. Okay, so simplifying this, we have the 8th root of x to the 4th. Okay, so to convert that to a rational exponent, what I would really have is x to the 4/8, and 4/8 reduces to 1/2. And we know anything to the 1/2 power is just a square root, so that would simplify to the square root of x. In letter B, we have the 6th root of 25. So I'm going to rewrite that as a rational exponent first. That would be 25 to the 1/6 power. And 25 I can actually express as 5 squared. So I'm just going to replace the 25 with 5 squared and leave the 1/6 on the outside. Okay, and I have two powers next to each other, a power to a power, so I'm going to multiply. 2 times 1/6 is really just 2/6, which reduces to 1/3. So this is really 5 to the 1/3, and as we learned in the beginning, anything to the 1/3 power is just a cube root. So this is really just the cube root of 5. And in letter C, I've got a 4th root of r squared s to the 6th. So what I'm going to do is, again, first rewrite it as a rational exponent. And I'm putting the expression, the radicand, r squared s to the 6th, in parentheses because it's an expression. That whole expression is being raised to the 1/4 power. And then I'm going to use my product to a power rule. I'm going to distribute the powers. I'm going to multiply them. 2 times 1/4 gives me 2/4, and 2/4 just reduces to 1/2. And then I have 6 times 1/4, which reduces to 3/2. So you can look at that like this. If you notice, both of the denominators are 2. My numerators are 1 and 3. So remember, those are your powers. So you could really express this like this. And you can check, because if I distribute my powers, I would get r to the 1/2 and then s to the 3/2. Remember, anything to the 1/2 power is a square root. So another way to write this would just be like this. And that's as simple as it gets. You can't really, simplify that much further. Okay, if you have any questions with 7.6, please let me know. And in the meantime, make sure you practice with your homework, and hope you all enjoy the rest of your day.